Welcome back again. Today we're going to talk more about fractions, but this time we're going to talk about multiplying and dividing fractions. We're going to start out kind of the way we did yesterday with a visual representation so we can see. Yesterday, by the way, is by definition the last time we met. That's what I tell my students all the time, so if I say that, you know what I'm talking about. We're going to do a visualization, but to begin with, I want you to just think a little bit. If I have 2/6, what would 1/2 of that be? Now remember, the denominator tells us what we're dealing with, so what are we dealing with here? Okay, sixths. How many of them do we have? 2 of them. What would half of that be? 1 of them. So 1/2 of 2/6 would be 1/6. In math, what operation does the word of tell us we're going to be dealing with? Okay, multiplication. So, excuse me, that's supposed to be a half. 1/2 times 2/6 is equal to 1/6. Now, inherently you know that, so just keep that in mind, and we'll talk a little bit about how we use that to help us with what we're dealing here. What we're going to talk about now is 2/3 of 4/5. And we're going to talk about it that way. We're not going to put the multiplication in there just yet, because I think you can envision what happens better if you think about this. So the first thing I'm going to do is I'm going to draw a 4/5 so we can see it. So here we go. 1, 2, 3, 4, 5. And what would 4/5 be? Okay, 4 of those. So what I'm going to do is I'm going to put a border around that. And that purple then is going to reflect 4/5. Okay? Now I want 2/3 of that. So if you had a pile of apples and you wanted to find 2/3 of it, what would you do? Okay? Split it into 3 equal packages or piles, and then you take 2 of them. 2 out of the 3. Okay? So I'm going to do the same thing here. I'm going to go the other direction now, and I'm going to make thirds. So I'm going to have 3 rows. So the 2/3 is going to reflect what I have in this area right here. That part there is going to reflect 2/3 of my 4/5. Okay, just like before, to be able to talk about this, we got to know the names of these little squares, because that's going to tell us what we have. So if we count them, we've got 1, 2, 3, 4, 5, 10, 15. So we're going to end up with 15ths. That's the name of those little squares. So 2/3 of 4/5 is going to be something to do with 15ths. Well, let's find out how many there are in this area here. I've got 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of those 15ths in that purple area. So 2/3 of 4/5 is equal to 8/15. Now, first of all, make sure you're clear that your brain sees that that is the case. 2/3 of 4/5 is equal to 8/15. And then I'm going to write that, 2/3, and now I'm going to put the equal sign in there. In place of the of, I'm going to be talking about 2/3 times 4/5. And when I do that, I know, we just looked at it, we saw, we get 8/15. it's really hard for the brain to visualize this kind of thing. 2/3 of 4/5. That's hard to even picture, get in your mind. But then to say that it's going to come up with 15ths when you don't even have any 15ths there, that makes it even more difficult. So this is one of those things in math where you just have to learn how to do this. You just learn that this is what you do. I mean, sorry, but that's the way it is. But what we do want to do is we want to be able to look at this and see if there's some way to get that 8/15ths, because again, we don't want to have to draw pictures every time and count a bunch of stuff if there's some other way that we can do it. So I want you to look at this for a second, the 2/3 times the 4/5, and the result we got, the 8/15ths, and see if you can figure out where those numbers came from. Given these numbers we had to work with, where did those numbers come from? Okay, think about it for a second. Does anybody see it? Well, look. 2 times 4 equals the 8. 3 times 5 equals the 15th. Now, you may have heard, somebody may have taught you that when you multiply fractions, you multiply straight across. That's okay if you can handle that and you don't get mixed up on it, but you might want to think about it a different way, and I'll show you the problems that sometimes happen. Notice, if I multiply the numerators together, I get the numerator of my product. If I multiply my denominators together, I get the denominator of my product. So I like to teach my students to do this. Numerator times the numerator equals the numerator. Denominator times the denominator equals the denominator. One of the reasons that I like to do that is because sometimes people get confused when they have something like this. If I have 2/3 times 5/3, then their brain kind of goes back to addition and stuff like that, and they see that the 3's there and the 3's are the same, and they say, oh, the denominators are already the same. I just put a 3 down there, and I'm done. So they end up getting as an answer, 2 times 5 is 10, and in the denominator they get a 3. That won't happen if you think numerator times the numerator equals the numerator. 2 times 5 is 10. 3 times 3 is 9, and that's what you'll get rather than the 3. So that's what my recommendation is to keep this straight. Just remember, when you multiply fractions, you multiply the numerator times the numerator to get the numerator, and the denominator times the denominator to get the denominator. Now, the reason you don't need to have the same denominator when you're multiplying is because in a real sense, you're not dealing with two different things. If you look at what we had before, 2/3, we talked about 2/3 of 4/5. The only real thing that I was dealing with there was the 4/5. That 2/3 that was mentioned there just tells me that I want a certain part of that, 2/3 of it. So if you're only dealing with one thing, in that case, fifths, you don't have to worry about getting a common denominator. You just want a part of 4/5. So remember that, and remember this rule for multiplying fractions, and that'll help you avoid the problems that sometimes people have. So let's just do a couple just for practice, see what we can get. Get rid of all this. If I have 4 9ths times 3/5. Now this is multiplication. So what's my numerator going to be? Doesn't matter that the denominators are not the same because we're not adding here. It's only an addition subtraction. You have to worry about that. My numerator will be 4 times 3. And that's 12. My denominator will be 9 times 5, which is 45. But what do we always have to check for before we say we're finished with any fraction? Can we reduce it? Okay, is there a common factor between 12 and 25? Well, yes, there is. This number is 4 times 3. This number is 15 times 3. There is a common factor there that we can use, we can take out, and our answer should have been 4/15. I don't know about you, but if you think about that, you might get into a situation where you start multiplying fractions and you could get some pretty big numbers. And looking at it and trying to tell, 12 over 45 may or may not be too bad. It's going to be a problem for some people, maybe not for others. But if there were some way to make this a little easier and prevent problems, wouldn't that be a good thing to do? So, going back to where we had 1/2 of 2/6, and we got 1/6, how come we didn't get to, let's make a multiplication so we can see it, how come we didn't get that 1/6? If we just follow the rule, we'd go 1 times 2 is 2, 2 times 6 is 12, so our answer should have been 2/12. Granted, we would have to reduce it, but we got to this 1/6 just by figuring it out in our heads. So let's see if there's something we can do here that will help us save the time when it comes to that kind of thing. 1/2, notice, and here's the key, multiplication is commutative. Since I multiply the numerator times the numerator to get the numerator, it wouldn't make any difference whether I multiply 1 times 2 or 2 times 1. So I could actually reverse that, put the 2 there and the 1 there. Now notice, I have a common factor in my numerator and denominator. There's a 2 right there in that same fraction. There's a 2 that's common to those. And anytime we have a common factor in a fraction, we can take it out. So we're going to expand that just a little bit now and maybe save ourselves some time. As long as we understand that multiplication is commutative, so I could write it that way, why don't we just say, if there's a common factor, and we're multiplying now, if there's a common factor anywhere in the numerator and anywhere in the denominator, we can take it out. So when I get ready to multiply this one, I would see right there, I can see them, they're right there. I can take out those factors of 2. So now I'm left with my numerator being 1 times 1, which is 1, 1 times 6, which is 6. Let's go back up here and look at this one. Because if I had known that then at this point in time, here's what I would do. It's good if you have some way you always do it. You always do the same thing because then you know what to do. So I'd look here first and I'd say, okay, this one's in the numerator. Are there any factors of 4 anywhere in the denominator? Doesn't have to be a 4, just any factors of 4. There isn't. So then we come down here and I say, okay, the 9 is in the denominator. I'm going to be looking in the numerator because one of them has to be in the numerator and one has to be in the denominator to give us that 1. So I say, are there any factors of 9 anywhere in the numerator? I look at the 4 and I look at the 3 and I say, oh, wait a minute. There's a factor of 3. So I can take it out. Then I check over here and there's nothing else I can do. So now when I do numerator times the numerator, I go 4 times 1. The denominator is going to be 3 times 5. And I get that 4/15, and I didn't have to worry about reducing it after I'd already multiplied. So doesn't that make sense? Let's make it the way we do things. We're going to just say automatically, when we multiply fractions, the first thing we're going to do is we're going to reduce. And I'll add from now on, whenever I say that, I'll say, first thing you do, if you're smart, Because if you're smart, you deal with the numbers when they're smaller. And then when you get finished, if you've taken out all the common factors, they don't come back. They're gone. And so you won't have to worry about reducing this final product. So let's just make that our practice then. We multiply the numerators times the numerators and denominators times the denominators, but only after we have taken out any common factors. Okay, I think I'm going to let that be enough, and we'll deal with division and a little bit of review and do a little practice with the multiplication of fractions. But let's do a couple of multiplication problems first, and then we'll call that good. Let's take 4/5 times 15/24. That's our problem. We're doing multiplication. And what's the first thing we do if we're smart? Look for that common factor. So I start right here. And I do it that way just because that's normally, if you watch me write it down, that's the way I wrote it down. But it tells my brain knows that that's automatically where they start. So we go right here. I say to myself, okay, this 4 is in the numerator. Where am I going to be looking? In the denominator. So I look at these two numbers in the denominator and say, any factors of 4 down there? Oh, wait a minute, sure. I can divide up 4 out of that one. Then I look down, I come down here because I can't do any more there. I do everything I can, but I can't do anything more there. I come down here and there's a 5. It's in the denominator. Where am I looking? In the numerator. Now, I don't quit until I'm done. Jenny Craig does not have you reduce for a while and then give up. She wants you to do it completely. So I come up here and try this. I got a factor of 3 in my numerator. So I look at my denominator. Are there any factors of 3 anywhere in the denominator? Well, yeah, right here. So I can divide that out. Now I look at what I've got left. There's nothing else I can do. So now I multiply my numerators together, and make sure you remember this. This is 1 times 1, and that's equal to 1. 1 times 2 for my denominator, that's 2. And so my answer is 1/2. Spend some time with this. The next one we deal with, we'll talk about dividing fractions, so we'll do a little bit of reviewing of multiplication, so there'll be a little bit more then. But take the time to get this down, figure it out and everything, and then we'll see you next time.